And we're live! Welcome to RockSim Live. I am Tim Van Milligan. I am your host. It is Friday, October 27, 2023. This is where we're talking about RockSim, the RockSim Pro software, and the Launch Visualizer. We're here to answer your questions, so hopefully you got a lot of them about RockSim because I have nothing to talk about. So I am dependent on you to ask questions. So what do you want to know today? I do have the live chat going on, so you can type in your answers. There's a lot of viewers, but nobody's talking yet. We have Jeffrey Gorotowski saying there's a huge lag. Does that mean like my lips are moving and my voice is coming in later? Or am I just a huge lag? Could be. Chris's Rocketry and More is here saying hello. Terry Wheelock is here. He says, start the training. Okay. What else are we going on? So if you are watching live, like I said, go ahead and type in hello. We'd like to recognize you and also where you're watching from. Just to see if we got an international audience going on again today. If you are watching on replay, we do these on Friday afternoons at 2 p.m. Mountain Time Zone. And it just happens to be 2 p.m. Mountain Time Zone because I was doing it earlier in the week when we first started, but then I had a weekly meeting. So I had to push this somewhere else, and so it got pushed to Friday afternoons. It's like you have nothing better to do on a Friday, right, than to watch me. But here's where we are on Friday afternoons, and yeah, we got a core group that seems to show up. I don't know why, but maybe it's my charming voice. I'm not going to sing a song for you. We got Julie from Indiana. That's a new name. Jeffrey Gortowski says, do you sim boost gliders with a pop pod? That's a good question. That's a really good question. So let me share my screen here and let's see if we can get started. Okay, so first, let me give you a little preliminaries. If you are brand new, if you've never heard about RockSim before, RockSim is a rocket design and simulation software. It runs on both Windows and Macintosh. And we have a cloud version. It's at rocksim.com. And we call it the Launch Visualizer. The Launch Visualizer is this little banner here, fly anywhere, anytime. The Launch Visualizer is really cool because it allows you to do it in the cloud. So it means you can be running the software on the rocket range and seeing it in 3D. So it's like Google Earth, except you have the rocket taken off and you can see the trajectory and where the rocket's going to land and see the smoke and the fire, and it's almost like it's the next closest thing to being there at a real launch. And then there's RockSim 10, which is where we're on now. And then we have RockSim Pro version 3. What we're doing right now is RockSim Live, which is the free training. And this little image is clickable. And if you click on it, it takes you to our archives. So we're on episode number 143, and this is what we talked about previously. So Jeffrey had a question about boost gliders. So if you want to find out if we've talked about something before, you can search this page, and you do that by doing a Control F on your keyboard or Command F on the Macintosh, and then you can type in boost gliders. And here is an episode number, we talked about it twice, episode number 69 and episode number 68. Can you simulate boost gliders in RockSim? And I don't know what we talked about before, so we will try it again. Maybe we'll try it in, maybe we'll try it again. Awesome. While you're on the Apogee website, go to the how-to and guides, click on that, and then come down here to software on the menu. And this gives you some more information about RockSim. Here's the free trial you can download. It gives you a 30-day free demo. You can purchase it. So if you're ready to use it forever, there's the purchase. What is RockSim? What are some of the features, the frequently asked questions, system requirements, and version history. There's also video tutorials. This is less of me and more just the how-to stuff. The RockSim live training is what we're doing right now, and then there's also videos for the RockSim Pro because it's a little bit different, particularly when you get into dual deployment, because flight events, it has more options, and so they can be a little confusing, so that you'll find that there under RockSim Pro. Terry Wheelock says, does RockSim work on the moon? We thought about that. That's a good question, Terry. We thought about, can you use RockSim on other planets? And basically, we need to know atmospheric information and gravity information. And for some reason, my camera's not showing up in the corner here. Let me see if I can fix that. There we go. Hey, there's my camera. Let me adjust my face here. Okay. So, talking about the moon, theoretically we could do it, but because the moon, there's no atmosphere, so that makes that part easy, and the gravity is 1/6 that of Earth. The issue is more, it probably could be solved pretty easy somewhere like under preferences. You can say, pick your planet. That would be pretty interesting, right? So how would you, but then people would say, hey, I got a wind on the moon. And say, no, you can't have wind on the moon. So there's some issues that would have to be resolved, but theoretically it could be done. But we've been designing, RockSim, particularly RockSim Pro and the Launch Visualizer. They're three-dimensional, and we bought the maps of the Earth. We use Google, or not Google. We use Bing Maps. Maybe I'll show you that in a minute, to generate the Earth. Like it's a globe, but we don't have that for the moon. I think Google has those maps available, but they don't have an API that we can plug into, which is why we're using Bing and Microsoft rather than Google. I like the Google Maps better myself, but Google doesn't make them available to people like us, where Microsoft doesn't care. So we're using the Microsoft Maps. But we would have to, if Microsoft had a moon map, we probably could do it. Sturk03 has a question. Can you run a dual deploy RockSim with a drogue parachute deploying at Apogee and then a Jolly Logic deploying at 500 feet? Will it give accurate data? Okay, I got the Katana Junior here, and the Katana Junior isn't actually a dual deploy rocket. We have two parachutes in here. We have one down here and one up here. So he wants to know, how do you set it up to do a main parachute at 500 feet? So the question is, How does regular dual deployment differ from chute deployment with a Jolly Logic chute release? So for those of you that don't know what a chute release is, if you come here to the Apogee website and you type in chute release in our search bar, it popped up there. So this is the chute release. And what it does, it reefs the parachute. And I'm just trying to see if I got a picture of it set up. There's all the parts. Basically, this is the little electronic gizmo, and there's a rubber band and a pin. And you take this part and you wrap it around your parachute. There's the pin. Oh man, I don't have a better picture. You wrap it around, there it is. So you wrap it around your parachute, and this is a little altimeter, and then you can set the altitude at which the pin is released, and then it unwraps the rubber band, which releases the parachute so that the parachute can deploy. So basically, it reefs the parachute and prevents the parachute from opening until the parachute gets to a certain altitude, and then it just uses a rubber band. There's no pyrotechnics in there. It just pops it out. The only thing is that the recovery device has to be out in the air, because if it's stuck inside the rocket and you release the rubber band while the parachute is still in the rocket is still in the rocket, and it doesn't have a way to get out of the rocket. So you have to throw this out of the rocket, let it fall down, attached to your parachute, and then at a certain altitude it's going to pop out. Okay, so that's how the Jolly Logic chute release works. So a typical dual deployment will have electronics here in the payload bay, and I have a parachute in this side and a parachute in this side. And to run a dual deployment, we load rocket motors. So I'm going to choose a rocket motor, and it doesn't really matter. I'm going to choose the F-29. And then you go to flight events, and I have two parachutes. So this first parachute is 12-inch diameter, so I'm assuming it's this one right here. And then there's one over here. This looks to be bigger, so that's 24. So my first one, I'm going to deploy it at Apogee, and then the next one, we will deploy it at an altitude, and we'll say, I'm going to guess 500 feet, but we have to make sure the rocket goes that high, and I'm not sure this rocket with an F-20 is going to go that high. We'll find out here pretty quick. So just looking at the starting state, the rocket is on a 98-inch launch rail. We'll probably make it 60 inches using a launch lug. Launch straight up. We're at an altitude of 700 feet. I like to run my simulations at 700 feet, just because that's kind of like somewhere in Iowa. So, kind of the middle of the United States. So that's kind of how I picked it. It's nothing really special. You can choose wherever you want. And I'm going to have a custom speed range. And what I'm going to do is going to set both of them at 8 miles an hour. So basically, this means it's a constant wind blowing across the field at 8 miles an hour, which is fairly breezy. And then we launch it. And it ran the simulation, and I'm peaking here. We went 2,026 feet. So our rocket did go greater than 500 feet, which is good. So the rocket, I'm running the simulation by clicking the start button over here. You can see the rocket taking off. This is the smoke drifting. So about this altitude, the motor burned out, and then it coasted. And then we have the first parachute deploying at Apogee, and so when it gets down to 500 feet, and you can see down here, I'm looking for 500 feet, the main parachute will come out. Now the drawing in RockSim doesn't change, but what you will, or the image of the rocket, so the parachute's not going to change. But what you'll see is the trajectory line is going to go more horizontal when we get to 500 feet because it's a bigger parachute. So basically it's drifting with the wind as it's descending. And so since it's descending slower and the wind is blowing it, it means it's going to kind of change course. So we're getting close here. All right, so now we're below 500 feet and you can see something change. See that little dog leg? And this is typical of dual deployment rockets. And so then the rocket's going to come down. I'm just going to speed it up here, and it landed down here. So now you can really see the dog leg. So these dots here in RockSim are 1 second apart. They're closer together here because the rocket is falling slower. So that's a typical dual deployment rocket. So how does a Jolly Logic, how do you set it up differently in RockSim? And the answer is it's identical. We just launched a Jolly Logic shoot release in RockSim. The only thing is that the parachute is still in the tube. So basically we have to move the parachute in the rocket to where it can come out of the tube. So RockSim doesn't care. It's basically the flight event says deploy the parachute out of the rocket. And so that's what we did. How it gets out of the rocket, RockSim doesn't care. It doesn't know. It's not smart enough to know. You have to know yourself that the parachute has to be pushed out of the rocket. Now, if you're smart enough, what you would do, as I said, was you take this parachute and move it into a location where it can be pushed out. So I would find this parachute, and you can just click on it. It tells you where it is in the parts tree. Then you can just double click to open it. And then we can change the location. You can see I can slide it around. And I can slide it into that back tube. I've moved the slider as much as I can move it, but here's the trick. You can always type in a number that's greater than what the slider bar allows. So if I type in 16 inches, you can see my parachute, this nice light blue parachute right here, move further back in the tube. And basically, we've done a dual deployment, or we've done a deployment with a Jolly Logic. Running the simulation is identical, so you don't have to change that. But that was a nice, easy question for me to start out with. Jeff Gortowski says, I imagine Heli-rocks are just really long strakes for simming. Yes. Because we can't simulate a rotating recovery device in RockSim. That's just like so complicated. So if you look at the Heli-rock design in RockSim, you would find that what looks like to be blades are just fins, and fins can't be deployed. So let's see if I got the Heli-rock here. So basically, it looks like it looks like the rocket going up, but coming down. Heli internal blades. I don't see it. Let me type it into a search bar, and then let me scroll down. Heli-rock. So open that up. Do I want to save that one? No. Okay, so this is what the Heli-rock looks like going up, and these blue blades are actually fins. You can see this is right up here. It looks just like a fin set, and basically that's how we put it in. But it doesn't spin coming down. So basically in this configuration, we can get a prediction on how high it will go, but we can't predict how slow it's going to come down because I can't spin the rocket coming down. But that was a pretty good observation. Jeffrey's talking about the moon. The chute has nothing to do on the moon. Yeah, deploying a parachute on the moon, not going to do anything. Julie Kaufman says, how to start a design for a level 3 rocket. Okay. Well, designing a rocket, it doesn't matter if it's an L3 or an L1 or your very first rocket like an Alpha. You're going to start out designing it the exact same way. So basically, when you're designing a rocket, you got to kind of like, what I do is draw a picture of the rocket on a piece of paper. Just sketch something out, what you think it's going to look like. From that, now you need to start selecting parts. So now an L3 rocket, that's a big rocket. L3 means you're flying an M motor or bigger. So you can do an M, an N, and an O. So you're going to be talking big components. An M motor is 4 inches in diameter. So at a minimum, the rocket's going to be 4 inches in diameter. Typically, they're going to be bigger. So now you got to find parts. So what I would do is I would go to the Apogee website. What we're looking for is just parts to design our rocket from. And then once we have some parts, mainly the nose cone, then we can start going into RockSim. So I'm going to go down, click on the shopping menu, come down to building supplies, and then come over to nose cones. So here's nose cones. And so it has different sizes, 24 millimeters, which is about an inch, 29 to 54 millimeters, about 2 inches, 56 to 98, so 98 is 4 inches. So this is kind of like the smallest nose cone. And then there's ones that are 5 inches or larger. So me, and this is your personal preference, is how big of a nose cone do you want to use? I did an L3, and I used the PNC 51, 7.51. So this is a big nose cone, and you can see the nose cone length. It's 22 inches long, and that's from the shoulder to the tip. It's 7.6 inches in diameter. So now I have a nose cone. So now I can start going into RockSim. So in RockSim, I would start out by doing a new design. So click on the new button over here, and it's going to ask if you have a design open, whether you want to save it or not. I'm not going to save it, so I'll just click no. So I'm going to start a new design, and we're going to work across these tabs here. So the first one is the rocket design attributes, and we might give it a name, L3 rocket. And we're going to use the RockSim stability equations. The side view marker size, when we get, this is like the CG symbol and the CP symbol. Right now, they're going to be drawn at 0.39 inches in diameter. That's good for a small rocket, but when we got a big rocket, we're going to be a 7.5 inch tube. I want my marker size a little bit bigger. So this is just a little tip. I'm going to make it 2 inches in diameter. You don't see anything yet, but you'll see it soon. Now I'm going to go across the next tab, and I'm going to go to the components, and I'm going to go to the nose cone. This is my first component, and I'm going to look in the database for, I wanted to click on the diameter. So the diameter, so I'm looking for that 7.5 inch diameter rocket. Not 0.7, I want 7. So 2 inches all the way down at the bottom. So here's the PNC 7.51, and click OK, and it loaded that into the design. So you can see my center of gravity symbol is pretty big, and my center of pressure. So that's what I wanted to do. I wanted to make them big. If you would have left it, the side view marker size small, they would be like really tiny. And I want to be able to see them. So then I click OK. Next, component. We're going to add a body tube. So when I design a rocket, I start at the top and work down. So the tip of the nose cone down to the bottom of the fin. So let's put in a body tube, and it's going to, again, look in the database, and I want to get that outside diameter at 7.67. So I'm just going to scroll through the list. I'm looking in this column right here for the big 7-inch tubes, and you can sort it. There we go. So I can choose this one right here, 7.51 inch. Click OK. And it loaded it, but it's pretty short. It's only 12 inches long. So now from here, I'd make it longer. Let's make it 60 inches long. Maybe let's go 80 inches, another 20 inches. I want a little bit longer. I like to, this is again my personal preference. I want to design a rocket that's stable, and I know that a length to diameter ratio of about 10 is going to give me make it pretty easy to make it stable. So if my diameter is 7.67 inches, then I want my length of the tube 10 times that. So at least 76 inches, and I made it 80 inches. So that's kind of where I got that number of 80 inches. This is not going to be the motor mount tube. We're going to put a motor mount tube in here later. And I'm going to change the color. This is my 3-dimensional color. I'll make it orange. And the 2-dimensional color, let's also make it orange or yellow. I'll make it yellow. Click OK. Oh, yellow's a hard color to see. There, make it a darker yellow. There you go, now we can see it. All right, so now I want to add fins to my body tube. So I have 4 choices of fins. I have regular fins, which are trapezoids or elliptical. Then I can do custom fins, which are any shape other than or including trapezoids and ellipses. Then I can do ringtails or tube fins, but I'm going to do just regular trapezoid fins. And it always looks in the database, and I'm going to cancel out of that. Once it's done looking in the database or you canceled out of it, RockSim is just going to draw some generic fins on here. And it's just throwing them on there as a starting point, and that's all it is. So now you can start changing, and I think these fins are massive. So, you know, each fin is 15 inches long. That's just like more wider than a piece, any plywood that I have. So I'm going to make it like that. And that actually looks pretty good to me. I'll just leave everything else, but you can move the slider bars around and change the shape to whatever fits you. Next, select the material. Since this is a high power rocket, balsa fins, probably not a good idea. Because balsa is probably not going to stand the stresses of a high power launch. So I'm going to make these plywood, and I'm going to use a 1/4 inch plywood, and I actually might make these even thicker. I'm going to make them 0.5 inches thick, and I'll make them rounded on the front edge and the back edge, so a little bit more aerodynamic. And then we'll come back to through the wall here in a minute. The color, I think we had orange, and let's make this one that color. Okay, so there's my fins on the rocket. Rocket is coming along pretty good. Now we need a motor mount inside of it. So I'm going to highlight the tube and do an inside tube. And now we're looking for a motor mount that can handle a 98mm rocket engine. So that's 4 inches in diameter. So I'm looking for something either 98 that says 98mm or that's, you know, outside diameter of 4 inches. So we'll use that tube right there. Click OK. You can see it drew it right here. It's in the wrong spot. So I'm going to change the reference location from the front of the the tube where it is right now to the back of the tube. And by doing that, I can change the length of the tube and the motor mount will follow it. So now I'm going to move this all the way to the back. So it's 0. You can see now my back edge is at the back of the tube. It's 34 inches long. I think there should be enough area in here for a big parachute. We're going to say this is a motor mount tube. And let's change the color. My rocket's going to be orange with a blue nose cone. The 2D color doesn't really matter. Click OK. So now we have the motor mount tube. Now we need fins, or not fins, centering rings. So we're going to put some centering rings in here. So I'm going to click on the body tube, come up here to centering rings. I'm looking for the component centering rings right here. Click on that. We're going to cancel out of the database. We're just going to let RockSim calculate it for us. And it's already calculated the outside diameter at 7.42 inches. It knows the inside diameter of that tube. This green line right here is the centering ring as it is right now. Again, I'm going to make these pretty thick because they got to be strong for an M motor. So it's a 1/2 inch. And this is where it takes a little bit of experience. You know, this is why there's a certification program, because as you go up the levels, you gain experience, and then you know from your own experience that thin plywood is probably not going to withstand the forces of flight, and I need to make it thicker. So this is, my thickness is based on my experience. And then I'm going to change again the location from the base of the owning part, and then I'm going to slide it back and watch what happens to the inside diameter right here when I slide this ring over this tube right here. You'll see that the inside diameter all of a sudden suddenly changes. So RockSim is pre-calculating that. So this is my front centering ring, so I'm going to put it like right there. Again, it's plywood, and color is fine. Click OK. So there's my first centering ring, and now I'm going to do another centering ring, and this time I'm going to do a copy and paste. So I'm going to highlight it, and then I can go to either to the edit menu and copy, or I can do a right click with the mouse, and it brings up this contextual menu. And then from that, I can select copy. And then I'm going to paste it onto the body tube. So I'm going to highlight the body tube and then bring up the menu again and hit paste. And you can see it put another ring here, but it put it exactly on top of the first one because we just basically copied it. Now we need to edit the location. So I'm going to double click on it. And I'm going to change the name to aft centering ring. And then I'm going to take the slider bar and I'm going to slide it all the way, mostly almost to the back. I'll leave enough room on there in case I want to put a screw-on retainer. Yeah, I'll do that. Then click OK. So now we have the forward centering ring and the aft centering ring. If you want to put a retainer on there, that would probably go on as a mass object. So how much does a retainer weigh? Here you come to the Apogee website and you type in retainer and retrainer. Retainer, screw-on retainer, retainer. Let's go here. There's an 18 millimeter. No, we don't want 18 millimeter. We want something bigger. Okay, so 98 millimeter retainers. So you go to building supplies, motor retainers and hooks, and then select 98 millimeter. Here is a flanged retainer. That's what we're going to have to use, that one right there. So I would select it, and find out the weight. Here's the weight right here, 230 grams for all of this stuff that goes into your rocket. So going back into RockSim, I would put a mass object back here that's 230 grams. So highlight the tube and come over here to mass object. Where are you, mass object? Right there. Click on mass object. It's going to look in the database. Just cancel out of that. So right now I put the mass object at the nose cone. We are going to give it a mass of 230 grams. You can see when I changed the weight, it moved the center of gravity of the rocket. And I'm going to put it from the base of the owning part, and the owning part is the body tube. You can kind of see, you know, which parts are owned by what. So the mass is underneath the body tube, so that's where it's going to be. And then we need to change the location. I'm going to slide it all the way almost to the back of the rocket. So a mass object shows up as a circle. In 3 dimensions, it actually shows up as a sphere. So it looks kind of crazy. Let me show you what that looks like. If I spin it around, oop, I'm not seeing it. I was going to show you a little trick, but I think I've turned the little trick already on. Under the color, I've turned the opacity down to 0, so I made it translucent. If I turn the opacity back on, we'll see our sphere. So there's the sphere, the blue sphere right there at the back. But it looks kind of creepy, so I'm turning it off by making the opacity 0, because a mass object, it's the mass of the item. A retainer doesn't affect the aerodynamics of the rocket, so that's why we don't have to worry about it so much, why we can substitute a mass object. All right, so let's go into the General tab, and let's call this the motor retainer. Okay, so we added the motor retainer. Now we need to add a parachute and a streamer. Oh, not a streamer. Parachute and a shock cord. So again, highlight the body tube. Let's put in a mass object for the shock cord. So this mass object is going to be a little bit different. Before, when we did the retainer, the classification was general. This time we're going to highlight that and select shock cord. And then we're going to select the material. And I want something really good. Here's 3/4 inch flat elastic. And now we need to change the length. Let me change it to 2D here. So here's the mass object for the shock cord. And the length, you know, it might be 20 feet long. 20 feet times 12 inches is 240 inches is 20 feet. And if I could have done that. RockSim calculated it on the fly. So there's 20 feet of 3/4 inch elastic. That weighs 74.8 grams. But we want to put that down over here. So I'm just going to grab the slider bar and just move it like right there. That's probably where the shock cord is going to go. We can change the color if we want. We'll just leave it alone. Oh, I should have changed that mass to shock cord so we know what it is. And then click OK. Now we want to put in a parachute. So again, select the body tube. And where's my parachute? Parachute right here. All right, and I'm going to click cancel out of here. This time, I'm going to let RockSim pick a parachute for me. It has some preset rates, and this will change the diameter of the parachute based on whatever rate I select. So if it's a low descent speed, I click on that, it tells me I need a minimum of 60 inches. I'm going to make this a ripstop nylon, give it a thickness, I don't know, 3 mil thick nylon, shroud line material. This is going to have to be some pretty heavy duty stuff. Let's go with tubular Kevlar for our shroud lines and make the length, I don't know, I'm going to make it let's try 72 inches. And I'm going to need a lot of shroud lines on this, at least 24. All right, so it gives me a descent rate of 18.9 miles per hour. The location of that parachute is right here. I'm going to slide it back a little bit further. I think this is probably a little too slow at 18 miles an hour. I'll probably want something bigger. So if I go to a 72-inch parachute, you can see now my descent rate is at 16. Still think that's a little fast. Let's try 84 inches. Now we're under 14.5 miles per hour. That should be slow enough. That's a big parachute though. And then the color is nice blue. I better make this 2D color a little darker. Oops, there it is. My color went underneath. Click OK. All right, so there's my parachute. So at this point, I'm going to save the design. I'm going to throw it on my desktop. Soon. Oh, RockSim crashed. And I lost all the work I just did. Should have saved it. Occasionally it crashes. Oh, man. Let's open it back up. Oh, man, this is why you should save it. I was going to save it. RockSim crashes. It's not very often, but when it happens, it's annoying. And it's always when you're opening a design or saving a design, never in between. So if you save often, it seems like the first time, if you can save it the first time, anything after that, it's going to be nice and stable. As far as saving goes, it's only when you at that point, it's when you might open a new design that it might crash. But at least at that point, you got it saved. Let's see if I can find something that looks like similar to what we just did, so I don't have to do it all over again. Because basically, the rocket was designed. I'm going to go through my list and see if something has a level 3 rocket. Well, I got a level 2. This is the level 2 kit, which is a little bit different. There's a Lock Goblin. I want something big. What's something huge? We don't sell anything bigger than a level 2 rocket kit, but there are rockets that are huge. Well, we'll just use... What the heck? Like I said, there we go. All right, so this is a Lock Goblin. This is similar to what we just designed. It's just a little bit smaller. And it's the rocket itself is 4 inches in diameter. So imagine it was 7.6 inches in diameter. And so now at this point you're running. It's just running simulations. So so we're ready to run simulations. So you go to run a simulation. You click up here, rocket pre-flight right here. Brings up the simulation properties. And you're going to choose an engine. You know, you might want to choose the biggest engine you can find. I can get a 54 millimeter L990 blue streak motor. And I'm going to have to do dual deployment on this because it doesn't come with an ejection delay. So under flight events, I'd select, you know, where I only have one parachute in here. So I can deploy it at Apogee, come on, select Apogee. Click OK. That rocket motor just barely fits. That's too long, so I gotta find something shorter. Let's go with a K535. Okay, so that fits in there. And now go back to that. Flight events deployed Apogee. We're still launching. We're at 98 millimeter. Our altitude changed. And we need to change this to custom. 8 miles an hour, 8 miles an hour. Click OK. I'm going to save it. I'm going to do a file. Save as. Put it on my desktop. Okay, it's saved. Now we're going to launch it. So I can go back here and we can either click launch or flight profile. They do the same thing. The flight profile will bring up the flight profile though. It's still loading here. Terry Wheelock says, save early, save often. He's right. So there's the rocket on the pad, and when we launch it, rocket takes off, goes up, and going pretty high, 6,000 feet. Still going, 7,000 feet. We're getting close to the top. It's slowing down. I can tell it's slowing down because the dots are getting closer together, and the rocket just went horizontal, so we reached apogee, and now our parachute is out. Remember, this is a, well, I don't know what size this is, but it's going to take a long time to come down. 283 seconds, so several minutes to come down. And it drifted 2,313 feet downrange. So this is a good case for dual deployment. And like we did before, basically to run dual deployment, you just need 2 parachutes in the rocket. Because RockSim can't tell how they're deployed. It just needs to know that there's 2 parachutes. So if I select the body tube and add another parachute, here's another parachute. And we'll make this one 18-inch. So let's make this the smaller one. We'll call it the drogue parachute so we can tell it apart. And click, oh, well, it's right here right now. Oh man, the thickness is huge. Okay, so it's still in the wrong location. So let's move that location back here. Right there. Oh, I moved it too far back. So this would be like a configuration where you would use the Jolly logic on the main parachute. So the small parachute is, they're both kicked out. The small parachute immediately inflates, but the big parachute is held together by the Jolly logic chute release. And it's not going to deploy until we get lower in the sky. So let's do a simulation. Flight events. So now we'll see 2 parachutes. We have the regular and the drogue. So this one, we'll select it at deployed apogee, and then the big one, let's deploy it at an altitude of, what do we say? This one went over 6,000 feet. Let's deploy it at 500 feet. So just type in 500 and click flight profile. Okay, and when it gets done, okay, so this one, see they roughly went the same height. There's a little bit of difference because this one actually went higher, even though we added another parachute. So basically you have to ask a question, why did this go higher when we added weight? Well, there could be a number of reasons for that. One is there's an optimum weight for every rocket motor based on the configuration of the rocket. It's kind of like a wiffle ball versus a baseball. They're about the same diameter, but which one can you throw farther, a wiffle ball or a baseball? And the answer is the baseball, even though it's heavier, but there's an optimum weight, and the wiffle ball is way too light. It doesn't have enough momentum once it's going to counteract that drag. So that's why sometimes a heavier rocket can go higher. The other thing is maybe the trajectory changed. Maybe because it had extra weight, it wasn't affected as much by the wind, so it didn't weathercock into the wind as much, and so it went straighter. Could be either one of those. I'm not, without digging into it, I couldn't tell you. But we'll launch the rocket. The rocket takes off, and I'm going to speed things up because I just want to see it get to apogee. So at this point, the drogue parachute came out, and then we're going to move it along until we get to 500 feet. And then our main parachute came out at 500 feet, which was right about there. And this time it only landed 736 feet downrange. So by doing dual deployment, we saved ourselves a lot of walking time. So that's what the trajectory will look like. Yeah, so designing any rocket doesn't really matter what size it is. It still takes about the same amount of time if it's a small rocket or a big rocket. So hopefully that answered your question, Julie. Alfred Indy has a question. It's a fun one. On the moon, can you launch a half-A motor and have enough thrust to lift an Apogee Zephyr? Okay, I can't do it in RockSim because we can only simulate on the Earth. So I'm going to have to do it in our head. So go here to the Apogee Zephyr. Type it in, find the Zephyr, and what I'm looking for is the weight. It has a weight of 44 ounces or 1,247 grams or 1.2 kilograms. Okay, so now we're going to go to the rocket motors. So let's go to rocket motors, go down here to rocket motor. So what did we say the Zephyr weighed? Come on. 1.2 kilograms. So now divide that on the moon, it's 1/6 the mass, or no, 1/6 the weight, not the mass. It still has the same amount of mass, but the weight will be different. So we'll divide that by 6. So 12 divided by 6 is about 200 grams on the moon is its weight. So now the question is, can a half-A motor lift 200 grams? So I'm going to go to shop, go to rocket motors, and he asked a half-A motor. So I'm going to 13 millimeter motors, has a half-A 3-2, and I'm looking for the maximum thrust of 7.6 newtons, and so I think it can just barely budge it. It's going to lift it just like, just going to kick it just a little bit, because 7.6 newtons is greater than 200 grams. It's not going to lift it. That's a good question. Okay, so let's so we can simulate that in RockSim, make our rocket 200 grams, and then put in a 7.6 half-A motor and see if it gets off the pad. Because that's what the equivalent is. So let's go to RockSim. I need to open a small rocket. And we're going to make it really heavy. Half a altitude rocket. Open that up. Save that one? No, I don't care. Okay, so here's my rocket, but I got to change the weight to 200 grams. Let's see what it weighs right now. Right now it only weighs 36 grams, so I'm going to put in a mass object inside the payload bay. Cancel out of that and make the mass 200 grams. Let's be close enough, even though this, I think I have two masses in here. I have that mass, forward, aft. Okay, so that's payload altimeter. Let's take that out. Delete. Yes. Okay, so we're 229 grams. That should have been 30 grams. Okay, and then we want to put in a half a motor. Choose an engine. Click OK, and then launch it. Let's see if it leaves the pad. It did. It got up to 1.6 feet. So it did leave the pad. So you could launch a Zephyr on the moon with a half a motor, but it's only going to go that tall. It's not going to go very high, but you could get it moving. That was a pretty good question, though. Julie Kaufman has question mark, question mark. What does that mean, Julie? Terry wants a Z motor. Can we design faster than light rocket? No. Einstein says no. I think that's all the questions. Oh, we did have the question about a boost glider in RockSim. Oh man, we're like out of time on the boost glider. Let's see. Do I have a boost glider in here? We have a mini Condor. And if I go to the Apogee website, find a RockSim file. There is a RockSim file for mini Condor. So let's download it just by clicking on it. Downloaded it. Oop, I downloaded it twice. Where did it put it in the downloads folder? My downloads folder is right here. Open downloads. There it is right there. Let's open it up. I gotta go back to RockSim. Where's RockSim? There's RockSim. Click cancel there. And just drag it on there to open it up. And does it ask me to save it? And I say no. And it failed to parse the content. It didn't like that file that I just downloaded. Let's try this other one. Oh, because it was a zipped file. I gotta unzip it first. Oh, I unzipped both of them. There it is right there. Okay, so the mini Condor, if I open it this way, save my changes? No. Okay, so there is the mini Condor. Let's see if it's set up as a two-stage rocket. Nope, it's set up as a single stage. So you can design it in RockSim, but it's not set up as where the pod falls off like it does in real life. In order to do that, that's why I was wondering if it was set up as a two-stage. Because that's the only thing I could think that would allow us to simulate it where the pod falls off. But does the glider glide? And the answer is no, because RockSim assumes that all the fins are on straight and they're not canted. I really need to work on something to do a sample design of a rocket where the fins are canted, and see if it actually does glide in 3 dimensions. I'm not sure. It might. You'd either have to use RockSim Pro or the Launch Visualizer, because those allow you to cant the fins, where RockSim itself does not. RockSim's our older software. It's the cheaper one. And it can't do everything that RockSim Pro can do or the Launch Visualizer. So there is a boost glider. If you go to the Apogee website and you look for the Condor boost glider, and then you can download a RockSim file for that rocket right there. Let's see, there's what it looks like. The pod falls off for descent, but it needs it on there for ascent. Yeah, that's about how big it is. It's not very big. There's the pod. And there's the wing dihedral. That's what makes it so cool, is that thing. All right, we're after 3 o'clock. Interior Wheelock says, can we design a rocket that would go from the moon to the Earth? No, because again, we're launching. We can only launch from the Earth, but because we don't have RockSim set up to have the gravity of the moon or no atmosphere. Yeah. All right, lots of crazy questions, lots of cool questions. We will be back next week. Next week will be November 3, I think. So we'll be back again Friday, 2 p.m. Mountain Time is when we'll start. If you have any questions about RockSim before then, you can always email us. Just go to the contact form on our website. If you'd like it answered live during the presentation, just when you email us, just say you can answer it during RockSim Live, and we'll do it that. And if you have those questions, we'd love them, because that gives us some time to plan ahead. If I had known that the boost glider question was going to come up, I probably would have planned ahead. All right, so we're not launching tomorrow because it's cold out, and I think we're under a fire ban because there's a fire going on in Colorado that's pretty close to our launch site. And what they said was, in the county, they had diverted all the fire equipment to that forest fire, so they don't have fire equipment in the town to fight other fires. So they put the rest of the county on a fire ban. So normally we're not under a fire ban this time of year because it's a little cooler. But because there's a forest fire south of us by our launch site, we're under a fire ban. So, but tomorrow's not our regular scheduled launch. It's a week later, so I think it's November 4th. So hopefully that fire will be out by then, and we'll get back to normal launches. And we're supposed to get some snow here soon. Snow, whoo, the S word. Makes it harder to launch rockets. You can still do it. It's just harder because your fingers are cold. All right. Well, thank you, everybody, for putting up with me. I'm having a lot of fun. So thanks for allowing me to have fun. It's really great to see you guys. But in 5, 4, 3, 2, 1, go out and launch something.